Today's lesson is entitled Completing the Square. And this is another way, it's actually our third way of solving quadratics. So the first way was graphing, the second way was factoring, and today is our third way, completing the square. We have done this method before back in Algebra 1, but it is a difficult one, so it's one that students tend to forget more easily. So we are going to go back and review it and spend some time doing the different steps here. So the first thing they want us to do is just to solve these two equations using something called the square root property. What we're able to do is if we look at each side of this, with certain equations, if it's a perfect square trinomial, which remember that means that it can be written of the form x plus 7 squared, something squared. I can do that with this. So with these particular equations, these are the only equations that I'm going to say this is true for. We don't want it equal to 0. Because what we're going to be able to do is take the square root of both sides and solve the equation. So if I factor this, what two numbers multiply to give me 25 and add to give me 10? That would be x plus 5 and x plus 5. Well, I have the same thing twice, so I can rewrite that as x plus 5, the quantity squared. Well, this is going to stay the same over here. This equals 49 and equals 49. Well, now I have a squared over here that I want to get rid of so I can get to the x. I can take the square root of both sides. So this is just x plus 5. We can actually get rid of the parentheses now because it's just the x plus 5 is equal to, and remember when you take the square root of this, it's plus or minus 7. So now I have two different things. I could have x plus 5 is equal to 7, or x plus 5 is equal to negative 7. If this is the case, I subtract 5, x equals 2. Or I subtract 5, and x equals a negative 12. And those are my two solutions. So it's different this time because we factored it and then took the square root instead of setting it equal to 0. Could I have set it equal to 0 and factored? Probably, because these two things are whole numbers. Sometimes that might not always be the case. So let's try this again. Again, what two numbers multiply to give me 64, but add to give me a negative 16? It's going to be x minus 8 times x minus 8. And then we're going to carry down that 49. Again, I can write x minus 8, the quantity squared, is equal to 49. Because instead of us solving it and setting each piece, now you do not say x minus 8 equals 49 and x minus 8 equals 49. You can't do that this way. You have to take the square root of it and then separate the two different equations. So square root, x minus 8 equals plus or minus 7. So now I set, because I have two different numbers over here, so now I can split it. X minus 8 is equal to 7, and x minus 8 is equal to negative 7. So when I add 8, I get x is equal to 15. When I add 8, I get x is equal to 1. And those are my two solutions. So this way is a little different, and this is our goal. We want to be able to do this with all of our problems. So when we're looking at this, what we're going to be doing with completing the square is forcing both of them to be equal to a perfect square trinomial and a perfect square on the other side. We want to be able to take the square root of both sides and solve it this way for something different. It's a different method. So let's go ahead and take a look at another equation. The only difference here is that we have 32 and 20. Those are not perfect squares. That's okay. So this one I can still factor. We can still say x minus 3 times x minus 3, and it's equal to 32. So I rewrite that as x minus 3, the quantity squared, is equal to 32. Still take the square root. But this time we have x minus 3 is equal to plus or minus the square root of 32. Well, that's not a perfect square, but I can rewrite it a little bit. I can factor that out so that it's 16 times 2. Well, the square root of 16 is 4, so really I can say that that's 4 square roots of 2, plus or minus. So now this becomes x minus 3 is equal to 4 square root of 2, and x minus 3 is equal to negative 4 square roots of 2. Now when you have the square root in there, we can't combine it with another number because it's not simplified. So really when I add the 3, we're just going to get x equals 3 plus 4 square root of 2, and x equals 3 minus 4 square root of 2. That's the only difference. So really you can combine this and then give one answer of x is 3 plus or minus 4 square roots of 2. That's all the simpler we can get. I'm not going to make you go the whole way with a decimal. You do not have to create this into a decimal because this is the exact answer. So I'm okay with you leaving it here. Just make sure you don't leave it here. You want to separate that out and simplify that piece if you can with the radical. Let's go ahead and take a look at another one of these. We want to know, how do I factor 16 so that it multiplies to give me 16 but adds to give me 8? That would be x plus 4 times x plus 4 is equal to 20. Again, we have x plus 4, the quantity squared. And now we can take the square root of both sides. So I have x plus 4 is equal to plus or minus the square root of 20, which I can rewrite as the square root of 4 times 5, which is going to be plus or minus 2 square roots of 5. So I just separated 20 into something that was a perfect square, and then I took the square root of it and pulled that out. So x plus 4 is equal to plus or minus 2 square root of 5. When we have this, because you have the square root and we can't simplify it anymore anyway, I'm not going to rewrite this into two equations. I'm just going to say x is equal to negative 4 plus or minus 2 square root of 5. And I'm going to leave it there. Because again, I can't rewrite, well I could, but I'm not going to rewrite that square root as a decimal, so we can't actually add or subtract anything. So we're just going to leave it as negative 4 plus or minus 2 square roots of 5. Okay, now we're going to get into completing the square and what that means. There's really 3 steps to it. The first one is that we take half of b. Remember that b is always the coefficient of x. So it's always that linear term. If you have it in descending order, it should be that middle term is b. It's the same one we used for negative b over 2a when we were graphing. It's going to be that same thing. So it's that same number that we used to find the vertex, but now we're going to use it to complete the square instead. So we take b and we cut it in half. Then you square that result, so whatever that number is. So if your middle number was 6, you divide it by 2, you get 3. Now you square 3. Once you square it, you now add it to your original equation, so that you force it to be a perfect square trinomial. I'll show you how that works here in a second. So for our first example, they simply want us to rewrite this. We're not solving anything because there's no equal sign. We're just asking ourselves, what value of c is going to get me this to be a perfect square trinomial? So I've got to complete the square to find it. So b is 12, so that's my b value. So I'm going to take 12, I'm going to divide it by 2, and I get 6. Now I'm going to take that 6, I'm going to square it, and I get 36. That's my c value. So now my equation is x squared plus 12x plus 36. Because what two numbers multiply to give me 36 and add to give me 12? 6 and 6. So this is the perfect square trinomial that I could factor to be able to take the square root of both sides. That's all that's to it. Don't make it harder than it is. It's just you take b, divide it by 2, square it, add it. So divide it, square it, add it. So let's take this one again. We have our b value. Now remember, the negative is associated with it, so that's all part of the b value. So we have negative 14 divided by 2 is equal to a negative 7. Then I square that, so negative 7 squared is a positive 49. So we have x squared minus 14x plus 49. What two numbers multiply to give me 49 but add to give me negative 14? A negative 7 and a negative 7. Now our next several examples are going to be ones where we're actually going to be solving using completing the square. So what we're going to be doing is once we complete it, we're going to have to actually add it to both sides of the equation so that we can solve for x. Okay, so first thing, we want to separate and add the constant, because remember I said this is the one where we're not going to have it equal to 0. So you want to eliminate that term and say that we have x squared plus 8x, leave some space, is equal to 20. We want to add that 20 to both sides. Now we have to complete the square. So I'm going to take my 8, divide it by 2, and I get 4. I take that 4 and I square it so that I get 16. What do I do with that 16? I'm going to add it to both sides. So I have plus 16 and plus 16. Because whatever I do to one side, I have to do to the other. So this side over here, so this is kind of like a little aside. This isn't really part of the problem, just kind of a little aside. So now when I come down here, we're going to get a positive 36. How do I factor this? There's a key to this. There's a trick. You don't have to factor it like we have been. The number that it's always going to be, so I always want this to be x plus or minus something, quantity squared. The number that will always fill in this piece is whatever your b over 2 was. So this value here fits right down in there. So it's going to be plus 4. Square root of both sides. I get x plus 4 is equal to plus or minus 6. Separate it into two equations. X plus 4 equals 6. X plus 4 equals a negative 6. So we have x equals 2. X equals negative 2. And that's how you solve by completing the square. So the only difference, so we're kind of putting together everything we did in the last couple of examples. First, we had to complete the square. We isolated this. We had to complete the square. Then we went into what we did in those first examples where we square root both sides, separated it, and solved. So we kind of put together both of those things. Let's take a look at the next one. We have x squared minus 10x plus 24. Again, get rid of the constant. This term wants to move to the other side. We have x squared minus 10x is equal to a negative 24. Now I complete the square. Take negative 10 divided by 2 is equal to a negative 5. We square that negative 5 to get a positive 25. Now this number gets added to both sides. So I add 25 and I add 25. So when I complete the square, so again this was kind of separated from itself. So now when I come down here, I'm going to have x, this number, minus 5 squared is equal to negative 24 plus 25 is 1. Square root of both sides. We get x minus 5 is equal to plus or minus 1. So I have x minus 5 is equal to a negative 1. So x is equal to 4. Or x minus 5 is equal to 1. X is equal to 6. And those are our two answers for that problem. So it's not hard, it's just there's a lot of steps and you have to remember all of those steps. So be sure to be practicing these, memorizing these, studying these steps so that you're able to know them come time for the test. Because there will be problems where I specify solve by factoring, solve by graphing, solve by completing the square, and then eventually we'll get to solve by the quadratic formula, excuse me. Let's go ahead and look at some more examples of this. Okay, so we have 2x squared minus 5x plus 3 again. Isolate the 3. 2x squared minus 5x is equal to a negative 3. Now you might notice that something's different between this one and the ones we had before. There's a number in front of my x squared. We're not allowed to have that. Our a value must be 1. So in order for that to happen, I have to divide everything by 2. So I have to divide this by 2, divide this by 2, and we're going to divide that by 2. So that I end up with x squared minus 5 halves x is equal to negative 3 halves. I know some of you are going to ask me, can I make this into a decimal? No. You can. However, it's much, much easier, as you'll see in a few seconds, it's much, much easier and you're going to do better if you leave it as a fraction. Because squaring a decimal, you're going to have to use your calculators. When you square a fraction, all you do is you square the top and you square the bottom. So it's two individual numbers that you should know how to square, and you're creating a new number out of it. By squaring a decimal, you're going to get something that you're going to have to use your calculator for to square. And I don't want you doing that. I want you to be able to do this in your head, quickly, efficiently, and on the go. So what we're going to do is we have negative 5 over 2. We're going to divide that by 2. Because we're completing the square. So I have to follow my steps. So I take the b value and divide it by 2. So negative 5 halves divided by 2. Remember that when you divide fractions, you multiply by the reciprocal. So instead of dividing by 2, I'm really multiplying by 1/2, which is negative 5 over 4. That's my value. Now I square it. So negative 5 over 4 squared. Negative goes away. 5 squared is 25. 4 squared is 16. That's the value we're going to add to both sides. So we're going to add 25 over 16 to both sides. I guess I should have written it down here. So when I factor this, it's still going to be this. Minus 5/4 the quantity squared is equal to, well, over here, I need to make this have the same denominator because I can't add fractions with different denominators. So I have to be able to combine like terms. So what is 2 as a denominator? It's going to be 16. So when I multiply this by 8, I multiply that by 8. So we get negative 24 over 16 plus 25 over 16 is equal to positive 1 over 16. Square root both sides. Square root this, square root that. So we have x minus 5/4 is equal to plus or minus. It's always still plus or minus. Square root of 1 is 1. Square root of 16, 4. So as you see, by me keeping it a fraction, I can still do everything in my head as I'm going. I don't have to refer to my calculator and be reliant on that calculator. Because here I was able to just bring this down. Over here, combine my terms. I can take the square root. If you have decimals, again, you're going to have to go to that square root to actually find out what it is. Keep it as a fraction. So now I can separate it into two different things. I'm going to come over here and we'll erase it in a second. So we have x minus 5/4 is equal to a positive 1/16. X minus 5/4 is equal to a negative 1/16. Or excuse me, 1/4. Look at the wrong value. Add 5/4. Or excuse me, 6/4 or 3/2. Add 5/4. So we get 4/4 or just 1. And those again are my two answers. So it does make it longer when you have to do this. However, you're still following those same steps. You isolate the constant, divide by whatever your intro number, your leading coefficient is if you need to, then divide by 2, square it, add it to both sides, take the square root, and reduce. So let's go ahead and take a look at that next one. I'm going to erase this piece so you can go back and pause the video or rewind the video if you need to copy any of that down. I'm going to give myself some more room to work here. Alright, so again, let's isolate that variable. So we have 3, or isolate the constant. Negative 16. Now I divide by 3, because I have to get that equal to 1. So we have x squared minus 14/3 x is equal to a negative 16/3. Let's take this value, the negative 14/3, divide by 2, which remember that really means multiplied by the reciprocal, which is 1/2. So I get negative 14/6, reduce it, negative 7/3. Square it. So I get 49/9. That's the value we're going to add to both sides. So I have x squared minus 14/3 plus 49/9 equals, now we're going to have to add ninths to this, so I'm going to make it ninths and multiply by 3. So we get negative 48/3, excuse me, over 9, plus 49/9. That's going to be equal to a positive 1/9. Factor it. Again, it's that value right there. Negative 7/3 squared is equal to 1/9. Square root of both sides. Over here, we get x minus 7/3 is equal to 1/3, or x minus 7/3 is equal to a negative 1/3. Add 7/3, over here we get 8/3, that's one answer. Add 7/3, over here we get 6/3, which is 2. So if you need to, go ahead and pause the video, stop the video, whatever you need to do to make sure you get that all copied down, because I know there's a lot of details there. So make sure you have that all, make sure you're copying down all the steps. Remember that this is, yes, while this line here is part of the steps, you're really jumping from this one down to this one in your lineup of work. So this you could pull off to the side if you need to, if it confuses you to be there in the middle. We do have one more example I want to get through. So he wants to solve x squared plus 4x plus 11 is equal to 0. So again, let's isolate that. X squared plus 4x is equal to a negative 11. A is already 1, so we can just go ahead and divide by 2. So we have 4 over 2 is equal to 2. Square it. So we get 4. Add that to both sides. X squared plus 4x plus 4 is equal to negative 11 plus 4, which is negative 7. Factor this. Remember, it's this value here, so it's x plus 2, the quantity squared, is equal to negative 7. Square root, some of you may be starting to see what's happening here. If we get x plus 2, it's equal to plus or minus, said 2, row 7, plus or minus square root of a negative 7. Whenever we have a negative square root, what's that mean? It means we're going to have an I value. We are going to have some imaginary numbers with this. It's possible because those are no solutions. That's the thing too, we don't really have any that aren't solutions anymore because we have ways of solving for those no solution problems, the letter I. So I'm going to bring that over here. So if x plus 2 is equal to the positive square root of negative 7, which is going to be x equals negative 2 plus I square roots of 7. So all you do is pull that I out front and that's it. So I moved the 2 over and added that to it. So this is one answer. The other one is x plus 2 is equal to negative square root of a negative 7. So when I subtract 2, I get x is equal to negative 2 minus I square root of 7. So again, it's just that value plus or minus I square root of 7. So same idea, just make sure in the answer, if you have that negative, that you pull out the I, if that's the case. So your homework, I have altered it a little bit because I wanted to combine what we were supposed to do yesterday and what we're going to do tomorrow. So you're going to do 273, numbers 16 through 38, all of them. Some of them you're just finding the value you don't have to solve, some of them you're just solving. Some of them are going to have complex solutions, irrational solutions, all kinds of mixtures in there. So be sure to have your books with you in class tomorrow. Again, these note sheets were found on Edline if you didn't find them. You can go online and print those out. Go back and make sure you take the notes on that note sheet so you have those for the notebook quiz, which will be coming up here before long.